So we've defined the arc sine, arc cosine, and arc tangent in previous videos, and we're going to see a very similar way we're going to be able to define the arc secant function. So the idea is to take a graph of y equals secant of x, which is right there, and of course we see that it's not a one-to-one function, so its inverse is not going to be a function. Again, we can see that by looking at the line y equals x and doing the reflection of that, and we get x equals secant of y, which is clearly not a function. Okay, so let's get rid of that. So we want to keep part of this. Now we're definitely going to keep this part right here, where x is going from 0 to pi over 2. We don't want to keep this part because then, why not? Well, it wouldn't be one-to-one. We could pick one of these other parts like way over here, but then we'd have this big gap in it. So if we just go this part here and this part here between 0 and pi, that's going to be good. So we keep that part of the secant graph right there, and we do its inverse. Okay, so that's part of y equals secant of x, but just keep that part from 0 to pi. It includes 0 and pi. The only thing it doesn't have is right here at pi over 2. So this vertical grid line right here is a vertical asymptote. And we take it and reflect it over the line y equals x, and we get the arc secant. See, notice these two pieces are mirror images, and these two pieces are mirror images. Okay, so the blue one there is the arc secant or inverse secant. Again, we have various notations for it here. Okay, so let's look at some properties. Now let's get the graph of this on our calculator. When I put up this on the graph of the calculator, I can graph y equals inverse sine, inverse cosine, and inverse tangent very easily. But if you got a TI-84 calculator, for example, you notice there's no inverse secant button. So how could I graph that? I'm wanting to graph y equals, I'll write it this way, inverse secant of x. Well, if y equals inverse secant of x, this is part of the graph of x equals secant of y. Well, secant of y is 1 over cosine of y. Okay, now by the way, which part is it? It's this part. Where are the x's and y's here? Well, let's see. The x value here is a secant value. It's an output of secant, so it's between negative infinity to negative 1, or between 1 and infinity. And the y value, but there are infinitely many y values, there are infinitely many inputs for secant that could give you that, but we want to remember we restricted it to only the ones between, let's see, where do we go? We went from 0 to pi, like that, but then we actually skip over pi over 2. Okay, so this is the part that we restricted it to. So with that restriction, we can continue on. Now let's see, let's solve for this for y. So do the reciprocal of both sides. 1 over x equals cosine of y, and then we have y is the inverse cosine, I'll use your calculator notation, of 1 over x. Now where inverse cosine has, in general, inverse cosine has a y that's between what? 0 and pi, and that's basically what I have here. You're not going to get one at pi over 2 anyway. So this is going to, since these match up, this will work out correctly. So I can get this same graph. Okay, let's look back what the graph's supposed to look like. It's supposed to look like the blue one there. Let's hide the other one here. So that blue graph is the graph of the arc secant. Okay, and let's get the same graph on our calculator. So first of all, make sure I'm in radian mode, which I am, and then I want to graph inverse cosine of 1 over x. Let's graph it, and that's not a very good window, is it? So I need to go perhaps way out to the left and right. I only need to go from 0 up to pi on the x's, on the y's though. So I need to go up y's to go up to, actually that's pretty good, a little bit above pi, but maybe I need to go out quite a bit further. How about negative 10 to 10 on the y's, on the x's, and now we can see it. This actually comes right down to the x-axis right there, and this goes right up to y equals pi, but my graph's not showing it very well right there. Okay, so this is what the graph looks like. What are some properties that we have for the arc secant? Well, the domain of the arc secant is the same as the range of the secant, and that's going to be from negative infinity to negative 1, and union with 1 to infinity, including the 1 and the negative 1. The range would be basically from 0 to pi, but of course it doesn't actually have anything that gives you pi over 2. So it's from 0 to pi over 2 union pi over 2 to pi. It includes pi and 0, but not the pi over 2. Notice it does not cross the y-axis at all. In fact, it doesn't cross, it just doesn't cross the y-axis at all. In fact, it doesn't cross for any, it doesn't have any x values in this part in the middle between negative 1 and 1. It does have some endpoints. There's one right here. There's at negative 1 pi, and it has one here at 1, 0. It does have a horizontal asymptote right through the middle of the graph. That's right here at y equals pi over 2. And that corresponds, of course, to a vertical asymptote on one of the vertical asymptotes on the y equals secant of x. It is in two disconnected pieces, so it's not continuous. And notice that it does increase on each piece. It's concave up in the second quadrant here, concave down here in the first quadrant. So we can also think of it, of course, instead of this picture where the output is a y value, we can think of the output as being an angle over here. What kind of an angle? An angle between 0 and pi. And actually, of course, pi over 2 right there is not one of them. So it should be from here to here. You know, I can kind of illustrate that that one's not allowed by actually making that a white dot there to show that that one's skipped over. But these others are allowed. Okay? And if you want to do it in your calculator, you may have to do arc cosine of 1 over x. Now, if you have a TI Inspire, for example, it does have an inverse secant function built in.